This is Unit 6 Mastery Project for FRQ2. Part A is asking us to draw arrows to indicate the direction of the moon's velocity at both points A and B, and if the velocity is 0 at either right V equals 0. So, the moon is orbiting clockwise around a planet, and at velocity A, if you stop it, its velocity it has a velocity pointing upwards. Meanwhile, at point B, it has a velocity pointing to the right, which is why I indicate those two arrows. And for the acceleration, since the only acceleration in this problem is gravity, which is pointing towards the planet, which is why the only acceleration in this problem is the gravity from the planet, which is why at both points I pointed it towards the planet, which is why I got 3 points for this question, 3 out of 3. For part B, it is asking us, starting with the conservation of angular momentum, derive an expression for the moon's speed when it is at point B. And this was the image that they gave us. So initially at point A, initially the angular momentum is at point A, and at the end is at point B. So I put I times omega is equal to I times omega, and so I put the moon mr squared times which is v times omega, which is v over r, is equal to mr squared times v over r for point B. And the reason why I got this question wrong is because I didn't put sine of 53. As you see here, this should be sine. It doesn't make a perfectly 90 degrees angles, which is why usually you cancel out because sine of 90 is equal to 1. But since it doesn't, you have to include sine of 53, which is why I got the problem wrong. So in order to do it, Li is equal to Lf, and RMV, this is all for point A, is equal to RMV for point B, and then times sine 53. And you could get rid of the m, the mass, because the mass is the same for the moon at both points. So r sub a times v sub a is equal to r sub v times v sub v sine 53. And it told us that r sub b is equal to 5 over 2, which is 2.5, times r sub a. So you get rid of the r sub a on both sides, and sine of 53 is 4 over 5. So if you make this 4 over 5 and you multiply, is v sub a is equal to 2 v sub v, and you just move it to the other side. So v sub v is equal to 1/2 v sub a. This is the actual answer. So for part B, I got 1 point for using multi-step derivation that uses the conservation of angular momentum. I got 1 point because I did indicate that at point A is equal, the angular momentum is r times m times v of sub a, and at point B, and I lost a point because I didn't indicate for point B there was a sine 53 times r sub v times m sub m times v sub v, and I didn't solve the problem correctly. So for this problem I got 2 out of 4 points. For part C, So for part C, asking us to sketch a graph of the moon's kinetic energy as a function of its distance r from the planet, r sub a, r sub c, and so I sketched this pointing like increasing, and which is wrong. It should be decreasing because of the equation I derived in part B was wrong, and the velocity was on the numerator, which is why I thought it increases with its velocity, but it decreases, and my radius was also on the numerator, which is why I thought it increased, but yeah, it's wrong because it actually decreases, because the farther it is away from the planet, the more kinetic energy it has, or the less kinetic energy it has, which is why it should actually be decreasing from starting at Ka all the way to slowly decreasing downwards. It should look like this instead. And the reason why you don't start at 2 times Ka, because it indicated that the equation is 1/2 m times v squared, and that's for Ka. So it was a trick. And so for this problem, I lost the point because I didn't draw a curve that contains the coordinates Ra and Ka, because I had 2 Ka. I lost the point because I didn't draw it was inverse, which means it should be decreasing. And I lost the point because kinetic energy should never be 0, because the moon is always orbiting around a planet, in which I did indicate that was 0 at this point. So for this, I got 0 out of 3. Part D is asking whether the graph I drew in part C is consistent with the velocity and acceleration you indicated for point B in part A. And since I got the part C wrong and part B, I got this wrong because I thought it was W times R. And in reality, the reason why it is consistent, it should be consistent with this new equation and this graph, is because since the moon is farther away from the planet, it loses kinetic energy because the gravitational energy that the planet acts on the moon is less, because it is farther away, and it increases with distance, which is why the farther away, the bigger the radius is, the smaller the kinetic energy should be that the moon should have. And so for this problem, I got 0 out of 2 because I didn't just use the correct justification. So in total I got 5 out of 12.